Welcome to Peshawar Model School, Nashara campus. Hello students, hope you're doing good. I'm your chemistry teacher, Ms. Faradiba. Please don't forget to subscribe our YouTube channel so you will watch our upcoming videos. As you know that today we will going to proceed to the home task for the month of June of class 10 chemistry. But today we will discuss chapter number 10, acid, bases and salts, because as you know that our home task include 4 questions. The first one question from the class 10 chemistry unit number 9, chemical equilibrium, and second question is related to the chapter number 10, acid, bases and salts. And as you know that we didn't discuss this chapter in our previous lectures, but today I will firstly discuss the short summary of this chapter, and after that we will go to our question number 2. So now I will show you the summary of this chapter number 10, or we can see I will show you the mind map of this chapter. So after that you will easily understand your question number 2, and as you know that your summer task is for 50 marks, so you should have to do your home task because it will affect your midterm examination score. And for that you should have your separate notebook in which you have to do your home task. Okay, so now let's go to the summary of this chapter. Okay, now look at this mind map. Here you can see the acid, bases and salts. This is our chapter number 10. In this chapter we will discuss acids, bases and salts. Do you know what are acids? Acids and bases can be defined on the basis of 3 concepts. The one is the Arrhenius concept, the second is the Bronsted-Lowry concept, and the third one is Lewis concept. Okay, so now you can see that acids are those species which gives proton in any aqueous solution. This definition of acid has been presented by the Arrhenius concept. And if you look at the base, so look at this, bases are those species which gives hydroxyl ion in any aqueous solution. Means if we take example of water, so if we dissociate that in aqueous solution, so that if that give proton, so that will be the acid, and if they give hydroxyl ion, so that will be the base. So water can be treated both like acids and bases. Okay, the second one is the Bronsted-Lowry concept. Okay, so according to Bronsted and Lowry concept, acids are those species which donate proton, means which give proton to the other species, and will become negatively charged by itself. Okay, so now see that how what will be the base according to the Bronsted-Lowry concept. According to the Bronsted-Lowry concept, those species which accept proton, or we can say proton acceptor, so that will be called the bases. Okay, now the third one is Lewis concept. According to Lewis concept, acids are those look at this one, this line, this comes from the acid, and according to Lewis concept, acids are those species which accept electron or pair of electron, and according to Lewis concept, bases are those species which donate electron or pair of electron. So these were the definitions of acids and bases. As you know that we will discuss this chapter in detail, but for your summer vacation task I gave you a short summary of this chapter. So on the basis of this you will understand your question number 2. And the salts is the what are the salts? Salts are the neutralization of acids and bases. Means that if we react any acid with any base, and there must be the neutralization process, so as a result we will get the salts. Okay, now we will discuss that what are conjugate bases and what are conjugate acids. When an acid gives a proton, it forms negatively charged species which can accept proton and acts as a base and is called conjugate base of corresponding acid. Now look at the example. You can see that acetic acid, as name indicate that this is an acid. It has one proton, and if we replace this one proton, so there will become negatively charged species. Okay, now this acid is reacting with the water. Now water, as you know, that water can act both as an acid and base. So now in this case it will act as a base. Why? Because this oxygen is more electronegative than this carbon, so it will have pair of electron. So this pair of electron will accept this proton and will form H3O positive ion or hydronium ion. So this will become conjugate acid. And if we has been replaced this proton from this acetic acid, so there will become negatively charged species, or we can say the conjugate base of this corresponding acid. So these are the conjugate bases and this will be the conjugate acid. Okay, now let's go to the conjugate. Okay, now what is conjugate acid? When a base takes a proton, it forms positively charged species which can donate proton and acts as an acid and is called conjugate acid of corresponding base. Okay, now look at this example. Here you can see now water is reacting as an acid. Why? Because nitrogen is more electronegative than oxygen, because as you know that in the periodic table the oxygen will come first from the nitrogen. So nitrogen will be more electronegative than oxygen. So now this nitrogen has electronic pair, and this electronic pair will take the proton from this water. So what does it mean? So it means that acids are proton donors, which we have discussed according to the Arrhenius concept. So this will become NH4 positive ion, and this will be the conjugate acid of this ammonia base, and OH negative ion or hydroxyl ion. So this will be the conjugate base of this corresponding acid H2O. Okay, so I hope that now you will be capable of attempting question number 2. Okay, so now let's come to our question number 2. As we discussed what are acid and bases according to three concepts and what are the conjugate acid and bases. So now we will do our question number 2, which is the write the conjugate acid and bases of the following reactions. So these are some of the reactions for which we will write the conjugate acid and bases. The first one is when nitric acid react with water. The second one is hydrogen cyanide and water. The third one is when sulfuric acid react with water. Fourth one is reaction of acetic acid and water. Fifth one is reaction of ammonia and water. Sixth one is reaction of water and bicarbonate ion. Eighth one is reaction of hydrochloric acid with bicarbonate ion. Ninth is reaction of water and hydrogen sulfate ion. And the last one is reaction of sulfuric acid and ammonia. Last one is ammonia and hydrogen carbide. So these are some of the reaction, and now we will discuss their conjugate acid and bases one by one. Okay, so now let's come to their answer. The first one reaction is reaction of nitric acid and reaction of water. So now what will be their conjugate acid and bases? So the solution will be, now look at this nitric acid. As the name indicates that this is acid and this is the strong acid, so it means that will be the proton donor, because water now treating as base. So if this is the acid, so it will give proton to this water, because this oxygen which has a electron pair, it will accept this proton and will form hydronium ion, and this will be the conjugate acid of this base water which are treating as a base. And the left molecule is the nitrate ion, NO3 negative ion. So this will be the conjugate base of this nitric acid. So this one is the conjugate bases and conjugate acids of these two substances, nitric acid and water, because this is the acid and this is the base. Okay, so now let's go to reaction number 2. Now reaction number 2 is when hydrogen cyanide react with water, what will be their solution? Okay, so now look at this reaction. When hydrogen cyanide react with water, it will give cyanide ion and hydronium ion. Why? Because this hydrogen cyanide has positively charged proton and this has oxygen which has electron pair. So now when this electron pair accept this proton, so it will form hydronium ion and this will be act as conjugate acid. And the left one molecule is the cyanide ion, because it got negatively charged, so this will be treating as a conjugate base. Okay, so now let's go to the reaction number 3. Reaction number 3 is the reaction between sulfuric acid and water. As you know that sulfuric acid is a strong acid, so it means it will give proton to this water. Look at this reaction. When sulfuric acid react with water, it will give conjugate base of hydrogen sulfate ion and conjugate acid of this water, and this will be the hydronium ion. Why? Because the sulfuric acid has a positively charged proton, so when this water which has oxygen and this oxygen has electron pair, so when this attract this proton, so it will form hydronium ion, and this sulfuric acid will got a negatively charged ion, so this will be acting as the conjugate base. Okay, so now let's go to reaction number now look at reaction number 4. This is the reaction of acetic acid and water. So what will be their solution? Look at this reaction. Now acetic acid is reacting as an acid and water will be act as a base, because this oxygen is more electronegative than carbon, so the negatively charged ion will be on the water, and because of that water will be react as a base. Okay, so now when this negatively charged oxygen, this attack on the proton will get this proton in the form of positively charged hydrogen ion, so this molecule will got negative ion and will be act as an acetate ion, and this will be the conjugate base of this acetic acid. And now when water gets this proton, so it will react as a hydronium ion, and this will be the conjugate acid of this base. Okay, so now let's come to reaction number 5. When we treat ammonia and water, so what will be their conjugate acid and base? Look at this solution. This is the reaction of ammonia and hydrogen. Now ammonia is reacting as a base and water is reacting as an acid. Why? Because this nitrogen has electron pair more than the oxygen, so this will get this proton which is present in the water, because water forms from one proton and one hydroxyl ion. So if we react both of these, so this will comes in the form of ammonium ion, and this will be the conjugate acid of this base, and the other one will be the hydroxyl ion, because when we get a proton from this water, so the left one molecule will be the hydroxyl ion, and which will be act as a conjugate base of this acid. Okay, so now let's go to the reaction number 6. Okay, now reaction number 6 is when we treat hydrogen and hydrogen carbonate ion or bicarbonate ion. So what will be their solution? Okay, now look at this reaction. Now water is reacting as an acid and bicarbonate ion is a base. Why? Because carbonic acid is a treating as an acid, but here you can see that it left one proton already and go to one negative charge. So now this will be reacting as a base. So now in this water molecule there has been one proton and one hydroxyl ion, and when this bicarbonate ion got this proton from the water, so it will be form as this will becomes in the form of conjugate acid, or we can say the hydrogen carbonate or carbonic acid, and this will be act as a conjugate acid of this bicarbonate ion, which is the base. And now you can see that hydroxyl ion, which is the conjugate base of this water. Why? Because water had one proton and one hydroxyl ion, and that one proton has been taken by this bicarbonate ion, so the left one is the hydroxyl ion. Okay, now reaction number 7. Now we will treat hydrochloric acid with bicarbonate ion, same like that. In that reaction, water was treating as an acid, and now hydrochloric acid, which is a strong acid, now treating with the bicarbonate ion. So what will be their conjugate acid and bases? When this bicarbonate ion accept this proton, because this already has a negatively charged ion, so when this negatively charged ion got this proton from the hydrochloric acid, so this will be form carbonic acid or H2CO3, and this will be act as a conjugate acid of this corresponding base. And the left one is the chloride ion, which will act as a conjugate base of this corresponding acid, hydrochloric acid. So that was all about the conjugate acid and bases of all of the reaction. Now let's go to the reaction number 8, 9 and 10. Okay, now look at reaction number 8. When we treat water and bisulfonate ion, so what will be their conjugate acid and bases? Now look at this reaction. Here water is reacting as an acid, and hydrogen sulfate ion is reacting as a base. So now when this get this proton from the water, so this will be form H2SO4, which will be the conjugate acid of this bisulfate ion. And as we know that water has been formed from one hydroxyl ion and one hydrogen ion, so when one proton ion has been taken by this bisulfonate ion, so the left one will be hydroxyl ion, which will be the conjugate base of this water. Okay, so now let's go to reaction number 9. When we treat sulfuric acid and ammonia, so what will be their conjugate acid and bases? As you know that sulfuric acid is a strong acid and ammonia is a strong base. When we treat both of these, so what will be the conjugate acid and bases? Here ammonia is more electronegative and it has lone pair of electron. So when these lone pair of electron attack on this proton, because this has one proton also, so when this ammonia attacks on this proton, so it will form ammonium ion, and this will be act as a conjugate acid of this ammonia base, and the left one molecule will be HSO4 or bisulfate ion, and this will be react as a conjugate base for this sulfuric acid. Okay, so now let's go to reaction number 10 is when we react ammonia with the hydrogen carbide. So what will be their conjugate acid and bases? Now look at here ammonia is reacting as a base and hydrogen carbide reacting as an acid. Why? Because this has proton, means it is a proton donor, and it has electron pair, and when this electron pair has been taken by someone else, so that will be called the base, and by which it has been taken, so that will be called the acid, according to the three concepts of acid and bases. Okay, so now what will be the conjugate acid of this ammonia? When this ammonia in which nitrogen has lone pair of electron, and when that lone pair of electron accept this proton, so it will form NH4 positive ion conjugate which will be react as a conjugate acid for this ammonia base, and the left one is the carbide ion. Carbide ion are those species in which the carbon got the negative charge, so this will be the conjugate base for this hydrogen carbide, which reacting as an acid. Okay, so that was all about the conjugate acid and bases for any acid or base. I hope you will understand all of these reactions, and please note down in your summer vacation task notebooks, because it is for 50 marks, and it will be included in your midterm examination.